is Masliyana Izzati binti Ismail, and my matric number is 203279.
Hi, my name is Aidil Wajdi bin Rujhan, and my matric number is 198620.
Hi, my name is Nurul binti Ahmad, and my matric number is 201773.
Hi, my name is Siti Nordiana binti Yusuf, and my matric number is 200240.
Hi everyone, my name is Muhamad Aiman bin Muhammad Yusuf, and my matric number is 200755.
For millennia, the search for pure water has been pursued by humans. Criteria for purity have become more complex, more rigid, and more quantitative over time. However, the principles, methods, and material for purifying water have remained remarkably similar from the earliest recorded information of 2000 BC in ancient Greek and Sanskrit writings. After 1500 BC, the Egyptians first discovered the principle of coagulation. 500 BC onwards, Hippocrates discovered the healing powers of water. In 300 to 200 BC, Rome built its first aqueducts, and Archimedes invented his water screw. Then, years by years, many evolution in water treatment has occurred, and the first water filter for domestic application were applied in the 1700s. After cholera epidemic spread through water in 1854, lots of techniques for water desalination and drinking water standards were invented and implemented to prevent waterborne illness. Water treatment experimentation today mainly focuses on disinfection byproducts. From the many methods of water treatment today that aim to make a safe water to drink, sedimentation filtration is one of the methods. Sedimentation method generally carried out in continuous flow type tanks that has influent zone, settling zone, effluent zone, and sludge zone. The water flows continuously in a horizontal or vertical direction at a slow and uniform speed. Its main principle is removing suspended impurities by allowing the water to stay undisturbed for some time in large tanks when most of the suspended particles settle down due to the force of gravity. The clear water can be taken out from the tank with the help of pumps.
Next, I will explain about the process of sedimentation with coagulation. Coagulation is a process in which certain chemicals known as are added in water so as to neutralize the changes of the particles so that the particle can come together to increase efficiency. In this picture, we can see how the coagulant traps impurities to the bottom of the tank. The overflow rate is about 3000 to 4000 liters per meter cubic per day, and the detention time is about 2 to 2.5 hours. For entire process of coagulation includes coagulation process, which is known as fast mixing. Next, the process continue by flocculation, which is also known as slow mixing, then followed by sedimentation. There are different types of coagulants used in this process, such as alum, copperas, chlorinated copperas, sodium aluminate, and lime. The dose of alum varies from 10 to 30 mg per liter. The most used coagulants in the industry is sodium aluminate. Next, I will pass to my partner to explain details about sedimentation.
Sedimentation tank, where the water is set for the flock particles to begin settling out at a faster rate. By simply adding and mixing aluminum sulfate into the water and let the water sit, this coagulant will allow the large portion of the sediment settle out to the bottom as sludge, which can be taken away to a landfill. The flock particles are automatically removed from the bottom of the basin, the clean water being the cleanest at the top due to the settling particles flow to the next stage of the process. In some plants, engineers actually use a dissolved air flotation tank in place of sedimentation basin. In these cases, air is pumped into the bottom of the tank, creating a cascade of tiny bubbles. As seen, these bubbles float to the surface and take flock particles with them, forming a film of flock at the surface of the tank. Then, a sweeper arm pushes the flock into the collection basin where it is taken to a handling facility. In dissolved air flotation tanks, the clean water is taken from the bottom where the least amount of flock is. When it comes to design water treatment plants, engineers will vary technique based on their water sources and how they want their final water to taste, feel, or otherwise be treated. The only regulation is the quality of the water being pumped to the city, and in most cases, it doesn't matter how plants get the water to that point, which allows civil engineers a lot of creative freedom in the process. After the majority of the solid were removed from the water will flow to the next step.
Next, let's move on to the advantages of sediment filtration. Firstly, it is one of the simple and low-cost technology to reduce settable solids and perhaps some microbes of water. It can be applied to large and small volumes of water using commonly available water collection and storage vessels. Removal of settable solids can reduce turbidities and make the water more amenable to other treatment methods to reduce microbes. Hence, less turbidity in water can improve penetration of UV radiation, decreases oxidant demand, and decreases solids-associated pathogens. And last but not least, sedimentation of filtration improves the aesthetic qualities of the water and thereby increases its acceptance by consumers. It is also recommended as a simple pre-treatment of household water prior to application of other treatments to reduce microbes.
Every system have their own pros and cons. You've heard about the pros, and now let's take a look at the disadvantages of sediment filtration. The first disadvantage of sediment filtration system is this system cannot remove chemicals smaller than 1 micron. Storing water for as little as few hours will only sediment the large, dense particles such as inorganic sands and silts, large microbes, and other microbes associated with larger, denser particles. However, clay particles and smaller microbes not associated with large or dense particles will not settle under these conditions. Second, we may need to combine with other types of filters. In some waters, solids are not efficiently removed by settling. For turbid waters containing non-settable solids, sedimentation will be ineffective and alternative methods of particle removal, such as filtration, are needed. Next, this system is found to be an unreliable method to reduce pathogens. Most viruses and bacteria and fine clay particles are too small to be settled out by simple gravity sedimentation. Therefore, microbial reductions by plane sedimentation or gravity settling are often low and inconsistent. In conclusion, sedimentation often is effective in reducing water turbidity, but it is not consistently effective in reducing microbial contamination. However, turbidity reductions often improve microbial reductions by physical and chemical disinfection processes such as solar treatment and chlorination, respectively. Hence, plain sedimentation or gravity settling of highly turbid water for household use is recommended as a pre-treatment for systems that disinfect water, since it is easy to perform and requires a minimum of materials or skill. It can be done with as little as 2 or more vessels by manually transferring, such as pouring and decanting the water. That's all for now. Thanks for watching.